Here's today's question, which is worth 35 marks. In part A, we have to match these three terms to their descriptions. The first description we're given is a statement that is accepted without proof. The term that describes this description is an axiom. An example of an axiom is that the angles in a triangle add up to 180 degrees. The next description is a statement that follows easily from a previous statement. This is a description of a corollary. This is basically a conclusion of a statement you've already wrote. The final description is an argument showing that a statement must be true. By process of elimination, you can work out that this description is the description of a proof. For filling out this table, we get an easy 10 marks. In B part 1, we have to find the converse of this statement. The converse of this statement would be, if a shape has 4 right angles, then it must be a square. In part 2, it asks you to say whether this statement is true or false. Obviously, this statement is false, as a rectangle is also a shape that has 4 right angles. So it's not true that if a shape has 4 right angles, then it must be a square. Part B is also worth 10 marks. In part C, it asks us for one of our proofs, which comes up almost every year on paper 2. The proof it asks us for is to prove that in a parallelogram, the opposite sides are equal. This is what your diagram should look like in the beginning. What we're given is a parallelogram with corners A, B, C, and D. Our goal in this case is to prove that the length of AB is equal to the length of DC, and the length of BC is equal to the length of AD. Our construction is to draw the line segment AC, which is the diagonal of the parallelogram. Now we have to start with the proof. Looking at our diagram, we can say that these two angles are the same, since our shape is a parallelogram, meaning that the line AB is parallel to the line DC. So these two angles are the same, as they are alternate. We can write this in our proof as follows. Another piece of information we can get from our diagram is that these two angles are also the same, for the same reason as the first two. We also need to write this into our proof in a similar way. Now we already have 2 equal sets of angles, and we only need one more piece of information to complete our proof. As you can see from the diagram, the triangles ABC and ACD both share this line, which is the diagonal of the parallelogram. Here's one way this statement can be written. As a result of these 3 pieces of information, we can say that the triangles ABC and ADC are congruent because they both share 2 angles and a side. Because the 2 triangles are congruent, this means that the corresponding sides are the same length. So AB is the same length as CD and BC is the same length as AD, which is what we are looking to prove. It's good practice to write the letters QED at the end of all your proofs. If you get this proof fully correct, you get 15 marks, which is the same for any proof in the Junior Cert paper. Thank you guys for watching this solution video. I hope it helped you, and I'll see you guys again.